Everything is made out of atoms, right? So, and this periodic table of elements is a chart that shows all of those building blocks. They're building blocks for every living thing, as well as all of the rocks and things that are not alive, even the air, right? So this is the chart of what they are, and they're organized. So like you've heard of copper and silver and gold, those are there, and you can see those. You also have heard about neon and neon signs. That's a gas, and so those are in, these gases are in neon lights, right? Here is hydrogen, and here is oxygen. Do you know what water's made out of?
Hydrogen and
Oxygen. Do you know the formula?
H2O.
H2O. So this is a molecule that we made that would be H2O. If we say there's two hydrogens, H2 means there's two hydrogens, and then the one oxygen. Okay? And it's bent like this because of the way the electrons and the all connect together. And so we put a stick in there as a bond to show what it's like. So my class has been making molecules, and we actually made all of the food molecules, or not all of them, but several examples of food molecules. And it looks like I lost one of the things. So this one has the green as the carbon, and so one of the foods, when we look at our food labels, it'll say how much carbohydrates, fats, and proteins, right? So this is a carbohydrate molecule, and it's actually called glucose is the name of this one. Oh, here's the other one. Okay, so this has yellow for oxygen, green for carbon, and red for hydrogen. And so if we count the carbons, there's it's a six carbon ring. One of them is an oxygen, and then actually this one should be a green one up here, because there's 1, 2, 3, 4, 5, 6 carbons and one oxygen inside the ring. So the formula for glucose is C6H12. So we should be able to count the yellows, and hopefully there's 12. And then O6. So there should be 6 oxygens. And then this is a fat molecule. You've heard of fatty acids. This is one fatty acid right there. And you may have also heard of triglycerides. Well, tri means 3, right? Like tricycle. So this has 3 fatty acids. See, 1, 2, 3 fatty acids, and they're linked together with this glycerol molecule. So a triglyceride is 3 fatty acids with a glycerol molecule. And so this is what a fatty acid looks like. And the cell membranes of our bodies are made up with 2 fatty acid chains, and then instead of all this, it has a phosphate on it. So it's called a phospholipid bilayer. And so those lipids are like this, coming together, right? Like fingers sticking out from the phosphate groups. And they don't like water because they're lipids, which are fats. And it's just like oil and water don't mix, right? And so we've got water inside our cells, and on the other side, right, this would be outside of the cell, that there's water outside the cell. But in between the membrane, it doesn't like water. Okay, and then what's the other thing behind carbohydrates and fats in food labels? Proteins, that's right. So this is an amino acid. So this would be a nitrogen atom, right? So nitrogen is here on the periodic table. right next to oxygen, right? Nitrogen and oxygen. See, there's carbon, nitrogen, and oxygen, right? So we learn those a lot because they're in a lot in our bodies and a lot everywhere in the world. So there's a nitrogen, like ammonia is in 3, right? So it would have 1 nitrogen and 3 carbons. Is that carbon? No, that's not carbon. It's 3 hydrogens. 3 hydrogens. So it's NH3. And it would have 3 hydrogens, but in this case, that nitrogen is connected to a carbon. So in this case, the carbons are yellow. So different people, different key. Sorry. So in an amino acid, so this is the acid side, there's an extra H up here for hydrogen, and so that makes it acidic. And then this R down here is that there's a whole nother molecule out this way. And it may be a carbon chain, or it may be a ring, different kind of molecule that kind of continues out here to finish the amino acid. But the reason that this is the important part of the amino acid is because that's the backbone for an amino acid. And so here we have 2 of them hooked together. Again, they used a little different key. In this case, the orange is nitrogen, and then we have carbon, carbon, nitrogen, carbon, carbon, and that's what makes the backbone of a protein. And this would have an R group here and an R group here. And if we wanted to hook this one together, let's see, it would have to go, would probably hook it over on this side, right? So the acid side and the nitrogen side would come together, and a water molecule would come out, and then it would stick together here. But and so that's how proteins grow, and you get big long proteins like the protein that carries oxygen in our blood is called hemoglobin, and it has like 100 amino acids, or more than 100 amino acids long. And depending on what's in this side chain of R, that depends on how it all twists up and works together as a big protein molecule in your body. So that's your carbohydrates, your fats, and your proteins. Any questions?
No.
All right.